Welcome to the RECOTRANS project. This is a granted European project within the Horizon 2020 framework and the Factory of Future program. The RECOTRANS project started in 2017 and it is due to be finished in September. During these 4 years, up to 13 partners from different countries and also from different levels have been working alongside with a very clear objectives. This is the development of integrated manufacturing technologies of recyclable multi-materials composite for transport sector. 3 different demonstrators have been manufactured for the truck, for the automotive and also for the railway sector in order to obtain novel products to make a more competitive transport industry. AIMPLAS, as a coordinator of the RECOTRANS project, has addressed alongside the consortium the achievement of the challenges in terms of production time reduction, energy saving, cost reduction and recyclability. From the recycling point of view, AIMPLAS has played a key role in the RECOTRANS project. For instance, this door handle has been obtained from the original door panel of the automotive sector. This means that the RECOTRANS project contributes to enhance the circular economy by improving high-quality applications for the transport sector.
In RECOTRANS, we are responsible for developing and testing the microwave cavities for pultrusion and RTM, which are modular and can be integrated with minor changes in existing modules and dies.
In RECOTRANS project, we are in charge of laser joining of glass fiber reinforced composite demonstrator and metallic components for truck and train sectors. In the case of truck sector, we are bonding a cab suspension unit made of RTM glass fiber composite with IC304 steel brackets. And in the train sector, we are working in the process of bonding the door panel of the train and AC304 steel inserts, where the emergency brake handle and the intercom unit are inserted.
The main purpose of the project is to develop a suspension unit with the new design created by our construction teams and made from composite as an alternative of steel, which is being used heavily in the transportation sector. Within the scope of the project, we aim to produce cabin rear suspension unit by using thermoplastic composite or metal-added thermoplastic composite material with the new method. By the means of microwave integration and laser joining technology, our major responsibilities started with the new design. Then our calculation department worked on the modeling and initial simulations. As a final stage, our mechanical testing teams worked on the physical tests and validate them with the final calculations.
The RECOTRANS project, we have been working driving the RTM process of thermoplastic resin from the first idea to one solution suitable for the automotive industry in terms of cost effectiveness. The use of thermoplastic materials gives us the opportunity to improve the recyclability of our composite components, and the implementation of microwaves during the manufacturing process reduce the polymerization time of the resin, and then overall the cycle time. We have achieved not only the initial target fixed in the RECOTRANS project, improved the cycle time using microwave steel values competitive for the automotive market, and proved the robustness of the process to be implemented in industrial conditions. We have identified the next steps to be improved before the technology will be ready to be used in mass production. The need of cooling of the part before the molding, and the use of prime coating to achieve A-class quality.
Being part of the RECOTRANS project, we have been investigating and designing the production of a material which is more recyclable. After all the work done to get this project and research forward, we can say that we are taking a great step forwards improving the recyclability of rail vehicles, and that we are at a turning point for the market to continue improving the final composition.
One of the CTAG's roles at RECOTRANS project is to evaluate the environmental, economic and social impact of the different technologies developed and their integration to meet the multi-material products based on the end user requirements. A life cycle assessment (LCA) is applied to calculate the environmental impacts of the products and technologies used as demonstrators in the RECOTRANS project.